Hi, this is Alfausia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is the product rule for derivatives. Here in this video, we can see how to use the product rule to find the derivative of the product of two functions. Let f of x and g of x be two different functions. The product rule says that the derivative of the product of two functions is the first function times the derivative of the second function plus the second function times the derivative of the first function. So this is the product rule formula. Here you can also take the first function as first and second. So if you look at this type, you can easily remember the formula product rule. Now let us see how to use the product rule in the problems. Let me take some examples and explain you. Here is our first example. If f of x is equal to 6x cubed times 7x raised to 4, find the first derivative, f dash of x. So here, did you notice that there are two functions multiplied with each other? So to find the derivative of this function f of x, we need to use the product rule. So let us apply the product rule here. Let this be the first function and this be the second function. So our formula says the derivative of a product of two functions is the first function times the derivative of second function, plus sign in between, second function times the derivative of first function. So let's do that step by step. Are you clear with this step? Actually, we didn't do any calculation in this step. We just applied the formula. Now we are going to find the derivative of the second function and first function and plug it in this step. So let this function be as it is. We need not do any calculation in this one. So for this one, derivative of 7x raised to 4. 7 is a constant, so you can take it out. X raised to 4 is a variable with an exponent. So we are going to apply power rule here. Power rule means n x raised to n minus 1. So 4x raised to 4 minus 1 is 4x raised to cube. So 7 times 4 is 28. So if you find the derivative of this function, you will get 28x cube. Am I right? Same way, let's find the derivative of 6x cube now. So keep this function as it is. 6 is a constant, so you can take it out. 6 times x cube. So you're going to apply power rule here. 3x raised to 3 minus 1, which is nothing but 3x square. Am I right? So 3 times 6 would be 18. So if you find the derivative of 6x cube, you'll get 18x square. Are you clear with this step? We just applied the formula in this step. Now we are going to simplify it further by multiplying. So here 6 times 28 is 168 and x cube times x cube. Here you can use the law of exponents. When the bases are same, you can just add the exponents. So 3 plus 3 is 6. So if you multiply these two, you will get 16x raised to 6. 168. Same way you can multiply these two terms. 18 times 7 is 126. X square times x raised to 4 is x raised to 6. We can add or subtract only the like terms. Am I right? Both these terms are with x raised to 6. So you can add these two numbers. So if you combine, you'll get 294. That's it for this example. Hope you're clear with this example. In this example, we took a very basic monomial. Now let me take another example with binomial or quadratic expression. Here is the next example. A function f of x is given. F of x is a product of two functions, 3x square minus 1 and x square plus 5x plus 2. In the previous problem, we just had only one term in each of the function. But here we have two terms and three terms. We are supposed to find the derivative of the function f of x. So we are going to apply the product rule since the functions are multiplied. So according to the product rule, left side would become f dash of x. Let's apply the formula for the right side of the equation. So we will get, keep the first function as it is, find the derivative of second function. Now plus sign in between and find the derivative of first function and multiply the second function as it is. You need not find the derivative for the second function. So this is our formula. Now we are going to find the derivative of each of the function wherever required. I have just taken this d over dx to each of the functions, each of the term within this parenthesis, so that I can explain easily for each term. Same way, find the derivative for each of the term in the first parenthesis for the second term. Are you clear with this step? Now we are going to find the derivative. Now for this term, we are going to apply power rule. So this would become 2x. And for this one, 5 is a constant, so I'm going to take it out, and derivative of x is nothing but 1. So 5 times 1 is 5. And again this third one, derivative of a constant. We know that derivative of a constant is just 0, so this term itself vanishes. Same way for this one, 3 is a constant, so I'm taking it outside and applying the derivative for x square. It would be 2x. So 3 times 2x is 6x. And derivative of a constant is just 0, so just ignore this one. So after this step we will get, now it remains to distribute it. This is just like FOIL method. You have to multiply each and every term in the second parenthesis by each and every term in the first parenthesis. Like 3x square times 2x, 3x square times 5. Same way, negative 1 times 2x, negative 1 times 5. And for the second term, you have to multiply each and every term in the second parenthesis by 6x. 6x times x square, 6x times 5x, and 6x times 2. So you will get, now we have to combine all the like terms. We have 2x cube terms, combine that, and only one x square term, and we have 3x terms. This is 30x square. So you'll be getting 2x square terms. So after combining all the like terms, we will get, that's it for this example. So whenever you're writing answers like this, you have to maintain some order. You have to start from the variable with the highest exponent and the next number. So x cube, x square, x, and finally a constant. So this is the order to write your exam in your final exam. Hope you're clear with this example. So these two are very basic examples. Now let me take some different functions. Here is another example. Differentiate this function without using the chain rule. Please notice that y equal to sine square x. This can be written as sine x the whole square. Am I right? So any number that is squared can be written as the number times itself. Am I right? So this could be written as sine x times sine x. So it is of the form product. Now you can apply the product rule. This problem can also be solved using the chain rule, but the question mentions it, you should not use the chain rule. So we are just using the product rule. So the left side would become y dash of x, and on the right side we will be getting first function times derivative of the second function plus derivative of the first function times the second function. So derivative of sine x is nothing but cos x. You can refer the formula sheet for this one. So sine x times cos x times sine x, which is nothing but sine x cos x, sine x cos x. Am I right? So which is equal to 2 sine x cos x. This can be rewritten as sine 2x from the identities. Hope you're clear with this example. Okay, now let me take product of an exponential function and a trigonometric function. Before that, in case if you're getting some variables, you have to write them in alphabetical order. Or in case if you're getting the same variable with different exponents, in your final step you have to mention it in the order like the greatest exponent first, next greatest exponent next, like that. Same way, when you're getting some trigonometric functions, there is some order to write your final answer. You should write the sine trigonometric function initially, and then cos, and then tan. So sine, cos, tan. So this is the order to write the trigonometric functions. So in this problem we just have sine and cos. So sine, cos. You have to rewrite this as sine times cos. Hope you understand this concept. Now let's move on to the next example. Here is the next example. We are supposed to find the derivative of the function y. Y is equal to e raised to x times cos x. So here we are going to differentiate this function as a product. E raised to x times cos x, the first function and second function. So apply the product rule. Before starting any derivative problem, you have to go through the formulas until you get practice. Now I have just applied the formula. First function times derivative of second function plus sign in between, derivative of first function times second function. So what is derivative of cos x? Yes, it is negative sine x. So e raised to x negative sine x plus sign in between, and derivative of ex is nothing but e raised to x itself times cos x. Now, did you notice that you have e raised to x as a common factor in between the first two terms? I mean the first and second term. So if you take this common factor outside and write the leftovers within the parenthesis, you will get sin x plus cos x. You can just arrange them. Because there is a negative sign in the first term, you can just swap the places. E raised to x cos x minus sin x. Are you clear with this example so far? The reason for swapping the places, rearranging, is all just for a good looking answer. It should look very pleasing. That's the reason we are just swapping the places. There is no harm even if you didn't change the place. If this is your final step, then it will be considered as a correct one. Just for a pleasant look, we are just rearranging and swapping their places. Hope you're clear with this example. So whenever you deal with some trigonometric function, you have to look at the identities. If possible, you can use the identities to rewrite the final answer. Application of product rule will be very easy when you get polynomial function. And no problem even if you get trigonometric functions. But it will be somewhat difficult when you get some exponential functions, square root functions. So you should be a little more careful while you're dealing with the other types of functions. You may also get some logarithmic functions. So first identify the functions and then you have to go through all the formulas given in the derivatives. So after going through the formulas, you can apply the product rule. It will be easier for you. The concept is very simple. Hope you are clear with this concept now. In case if you get any query, you